Hey everyone, and welcome back for another deep dive. Today we are talking all about computer vision and its role in powering AR and VR experiences.
Absolutely.
I feel like people hear AR, VR, and they kind of maybe lump them together.
Right?
But for those who maybe aren't totally familiar, AR is like Pokemon Go, right?
Yeah.
Where you're overlaying those digital elements onto the real world.
Yeah.
VR, on the other hand, you're creating those immersive digital worlds.
Right.
And I think what we're trying to get at today is how computer vision makes all this magic happen.
Right.
And I gotta say,
Yeah.
going through the research for this one, the applications for this are seriously mind-blowing.
Yeah. It's pretty amazing how it's being used. It
Yeah,
really is bridging that gap between real and virtual.
right.
It's not just about, making things look pretty.
Yeah.
It's about actually making the interactions feel real and
It's
believable.
like giving a computer sight. Right. I was looking at this article, Text Calais, and it was talking about how computer vision allows AR to overlay that digital information onto our world.
Yeah, and object recognition is a big part of that.
Oh, yeah. How does that work?
So imagine you're pointing your phone at a building, and it can actually see the building
Yeah.
using computer vision
Okay.
and pull up information about it.
Got it.
So it's actually processing what it's seeing.
Yeah. Instead of just taking a picture, it's like understanding it.
Yeah.
That's so cool. What are some of the other things that computer vision is being used for in AR and VR?
Well, there's simultaneous localization and mapping, SLAM.
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 Okay.
Yeah, it sounds a little complicated, but it's actually pretty straightforward.
Okay. Break it down for me.
So think about it this way. SLAM is how an AR app knows where you are
Okay.
and where to put digital objects.
So they don't, if I move my phone,
They
that's
stay in place.
yeah, they stay put as you move around.
And you can imagine without SLAM, you're playing a game and everything's constantly jumping around.
Right.
It wouldn't be very immersive.
Yeah. More like a bad acid trip than an AR experience.
Exactly.
Yeah.
So it uses sensor data, feature detection, and some complex algorithms to constantly build and refine a 3D map of the environment.
Mm-hmm.
And that's what makes things like virtual furniture shopping so exciting.
Yeah.
You can actually place digital furniture in your living room
Right.
and see exactly how it would look,
That's awesome.
all thanks to SLAM.
Slam.
Yeah.
That's really cool. And that kind of reminds me of depth perception,
Yeah.
which that same article, Text Callie, was talking about as well. I
Oh.
was reading about how it allows virtual characters to walk behind real objects.
Yeah.
It's like those little details that make everything feel so real.
Yep.
So how does that work?
So depth perception is all about the system understanding the 3D structure of the environment.
Okay.
So it's not just seeing a flat image. It's actually building a 3D model in real time.
Oh, wow.
Yeah.
So it's not just location, but spatial awareness within that location.
Exactly.
Okay. That makes a lot more sense.
Yeah, and then there's motion tracking, which is also super important.
Version tracking.
Yeah. So without motion tracking, virtual objects wouldn't stay lined up with the real world as you move around.
Right. So the illusion would be gone.
Exactly.
So what is it that makes motion tracking so important? What is it doing?
So it's all about the system being able to follow the movement of both the user and the device.
Uh-huh.
So this ensures that the digital elements seamlessly blend with the real world as you're moving around.
Okay.
And that's what makes some of those really mind-blowing AR videos possible, where characters are interacting with real objects.
Yeah.
Yeah.
That's awesome.
It's pretty amazing what it can do.
It really is. It's really pushing the boundaries of what we thought was possible.
It really is. And what's even more fascinating is that it's not just about passively watching. It's using our bodies and even our facial expressions to interact with these AR experiences.
Yeah. Okay. Yeah. Tell me more about that.
Okay, so think about gesture recognition.
Mm-hmm.
We've all seen those sci-fi movies where people are manipulating holograms with their hands.
Right.
Well, computer vision is making that a reality.
Wow.
So instead of fumbling around with controllers,
Yeah.
you can use natural hand gestures
Okay.
to interact with virtual
Yeah.
objects.
Got it.
And
Yeah.
that's something that Text Calais
Mhm.
highlighted
Mhm.
as being a much more intuitive and engaging way to experience AR.
Right. It seems like a lot more natural than using a controller or something.
It is, yeah.
But how does it work?
So the system uses computer vision to analyze the shape and movement of your hands,
Okay.
and it can then translate those movements into commands.
Right, so it's not just tracking where your hand is.
Right.
It's understanding what your hand is doing.
Exactly.
Oh, wow.
And then you have facial expression recognition.
Wait, hold on. We're going from hand gestures now to facial expressions.
Yeah.
What?
It's a lot, I know, but it's pretty fascinating.
Yeah.
So imagine AR experiences that can actually react to your emotions.
Whoa.
Yeah, they can actually change the storyline.
That's insane. Or the environment.
It's like it's aware of you as a person.
It is, yeah.
Oh my God. Okay, so we've talked a lot about AR.
Yeah.
But what about VR,
Yeah.
where everything is virtual?
Right.
How does computer vision fit into that?
Well, it might seem counterintuitive,
Yeah.
but computer vision is just as important in VR.
Okay.
And a good example of that is inside-out tracking.
Inside-out tracking.
Yeah.
What's that?
So inside-out tracking is how the system keeps track of your head and hand movements inside the virtual world.
Okay.
So that's what lets you lean in and look closer at something.
Okay.
Or reach out and grab a virtual object.
Got it.
All thanks to computer vision. So even though I'm in this digital world, it's tracking my movements and translating those into the digital world.
Exactly.
That's pretty cool.
Yeah, and sometimes it's even used to recreate real-world environments inside VR,
Oh, wow.
like for training simulations or
Wow.
virtual tours.
So I could be standing in my living room, but exploring ancient Rome.
Exactly.
Whoa, that's so cool.
Yeah, and that's just the beginning.
Okay.
Computer vision is also making those virtual reality experiences super realistic. It's used to create avatars that perfectly mirror your movements.
Wow.
Yeah, and Tex Kale was talking about how this really adds to the immersion
Yeah.
and makes the whole thing feel more personal.
Yeah, absolutely. Okay, so we've covered a lot of ground here.
We have.
It seems like computer vision is basically what is giving sight to both AR and VR,
It is.
allowing it to understand and react to the world around us, even our emotions.
Yeah, it's pretty incredible.
Yeah, this is definitely one of our deeper dives.
I agree.
It's a lot of information.
And we're just scratching the surface.
I know. I can't wait to get into even more after the break.
Yeah, there's a lot more to talk about.
So stay with us.
Yeah.
We're back, and we are diving even deeper into the world of computer vision.
Yeah, there's a lot more to uncover.
There is. And before the break, we were talking about how it's basically giving these systems a way to see and understand the real world.
Right, and one of the most fascinating aspects is spatial mapping and environment understanding.
Okay, so remind me. SLAM was all about tracking your location.
Right, knowing where you are in a space.
But spatial mapping goes beyond that.
Exactly.
Okay.
So instead of just knowing where you are, it actually understands the structure of the whole room or even the entire building.
Wow.
It can create a detailed 3D map.
So it's not just like placing virtual objects in an empty space.
Yeah.
It's integrating them into a replica of the real world.
That's a great way to put it.
Okay, so what are the implications of that?
Well, the applications are incredible. Imagine being an architect and using AR to visualize a new design. You could walk around a construction site and see the virtual building
Whoa.
layered right onto the real world.
That's insane.
Yeah, you can even walk through the rooms before a single brick has been laid.
That would be a game changer for architects and designers.
It is.
Yeah.
And it's not just limited to architecture.
Huh?
Think about interior design, urban planning,
Okay.
even furniture shopping.
Right.
Picture being able to see how that new sofa would look in your living room.
That's amazing. No more buyer's remorse.
Exactly.
I love that. I could definitely get behind that.
It's pretty cool.
It seems like almost every aspect of AR comes back to computer vision.
It really does. And that spatial understanding is crucial for object recognition and tracking as well.
Object recognition and tracking.
Yeah.
So we're talking about the system's ability to identify and track
Yes.
specific objects in the real world.
Exactly. So the system can recognize an object, provide information about it.
And even trigger specific actions.
Okay, can you give me an example?
Sure. Imagine a maintenance technician
Okay.
using AR glasses to repair a complex machine.
Right.
So the system could identify the components,
Uh,
provide instructions, even highlight potential hazards.
wow, that would be so helpful.
It would.
Yeah.
And the applications go beyond just industrial settings.
Okay, like what?
Think about educational tools, where students can use AR to interact with a virtual dinosaur skeleton
Oh, wow.
or dissect a digital human heart.
That's so cool.
Yeah, much safer than the real thing.
Yeah, a little less messy.
Exactly.
That's awesome.
It's all powered by computer vision.
Right.
It's basically giving these systems the ability to see and understand the world around us.
And as we were talking about earlier, to use our hands
Yes.
to interact with those objects.
Exactly.
Just like we use our hands in the real world.
Right. Gesture recognition is becoming more and more sophisticated.
Letting us control these AR and VR experiences
Okay.
with natural hand movement.
So we're moving away from those clunky controllers.
Yeah, we are.
I like that. They can be a bit of a pain sometimes.
They can.
Yeah, so how does the system differentiate, though, between me just like waving my hand around
Right.
and an actual command?
That's where those complex computer vision algorithms come in.
Right.
So it analyzes the shape and movement of your hands, your body,
Okay.
and interprets those movements as commands.
So it's not just tracking where my hand is, it's understanding what I'm doing with it.
Exactly. It's learning the language of our movements.
Wow.
And as these algorithms get better, our interactions will get even more nuanced. Imagine expressing emotions or even sign language,
Right.
all through gestures.
That's incredible. It opens up so many possibilities.
It does.
So much of this seems to come back to SLAM,
It does.
which we were talking about earlier.
Yes.
Can you like break down how exactly it works?
Sure. Imagine you're exploring a new city.
Okay.
You start to recognize landmarks, get a sense of the streets.
Okay.
You're building a mental map.
Right.
SLAM does something similar for AR and VR.
Okay.
It uses computer vision to track the device's movement and identify unique features in the environment.
So the system is creating its own internal map.
Exactly.
Wow.
And it's constantly updating that map as you move.
Okay.
So that's how it can accurately place those virtual objects, even if you're moving around or the lighting changes.
Right. Without that, the whole illusion would fall apart.
It would.
Yeah.
And it's this real-time mapping capability that makes some of the coolest AR experiences possible.
Okay.
You know, how you can have digital characters seemingly interacting with real-world objects or information seamlessly overlaid on physical products.
Right.
It's pretty amazing.
Yeah. So we've talked a lot about how computer vision helps these systems understand the real world.
Right.
But what about the virtual world? Like, how does depth sensing and 3D reconstruction fit in?
That's a great question.
Yeah.
So depth sensing, it gives the system the ability to perceive how far away things are,
Oh,
just like our own depth perception.
got it.
And that's really important for making virtual objects feel real.
Right. So they're not just flat.
Exactly. They have a sense of depth and volume.
Okay. And that's where 3D reconstruction comes in.
Exactly.
Okay.
It takes that depth information and combines it with other visual data to create incredibly detailed 3D models.
So it's building a digital twin,
Yeah.
but with like an extra layer of detail.
Exactly.
Okay.
Think about architects being able to walk through a building in VR before it's even built.
Whoa, that's amazing.
Yeah,
Or surgeons practicing on a 3D model of a patient's anatomy.
that's right.
That's incredible.
It takes virtual reality to a whole new level.
Yeah.
It really does.
So what technology is used to actually capture that depth information?
Well, there are a few different approaches. Some systems use specialized depth cameras that work with infrared light.
Oh, okay.
So they emit the light
No.
and measure how long it takes to bounce back.
So kind of like how bats use echolocation?
Exactly.
That's cool.
Other systems use multiple cameras to capture slightly different perspectives.
Okay.
And then algorithms use that information to calculate the depth.
So like giving the system binocular vision.
That's a great way to put it.
That's awesome.
And as this technology continues to evolve, the realism of our AR and VR experiences will just keep getting better.
Right.
We'll be able to interact with virtual objects as if they were really there.
That's so cool.
It's an exciting time to be following all of this.
All right, so we are back, and I feel like we've really been exploring some of the amazing things that computer vision is doing for AR and VR.
Yeah, it really is pushing the boundaries of what's possible.
It is, but you know, like with any powerful technology, I think it's important to also talk about the challenges.
Absolutely. And one of the biggest is the sheer processing power required for all of this.
Right, because it's a lot.
It is.
We're trying to fit like a supercomputer into a pair of glasses or a smartphone.
It's true. And we need those algorithms to be accurate and efficient, but also lightweight enough to run on devices that are comfortable to wear.
Okay.
And that's where edge computing comes in.
Edge computing, okay.
Yeah. By processing that data closer to the user, we can reduce lag and create more complex experiences.
So it's not just about the hardware.
Right.
It's about how the information is processed.
Oh, exactly. That's interesting.
And then you have the issue of robustness.
Robustness.
Yeah, these systems need to work reliably in all kinds of environments and conditions.
Right, because the real world is messy.
It is.
Yeah.
You know, you have changes in lighting, objects moving, people behaving unpredictably.
Right, it's like designing a self-driving car
It
that
is.
has to handle anything a city throws at it.
Exactly.
Yeah.
So there's a lot of research going into making these systems more robust and adaptable,
Right.
which involves training algorithms on massive data sets.
That cover all kinds of real-world scenarios.
So you're basically teaching them to expect the unexpected.
Exactly.
Okay, that's cool. But even with those advances, are there still like fundamental challenges?
There are. And one challenge is what we call the domain gap.
Domain gap.
Yeah.
Okay.
And it refers to the difference between the data we use to train those algorithms
Okay.
and the real-world data that they actually encounter.
So like studying for a test with one textbook
Exactly.
and then getting different questions on the exam.
That's a great way to put it.
Yeah.
And that can lead to errors.
How?
So researchers are developing ways to help systems adapt to new situations.
So teaching them to apply what they've learned to new situations.
Yeah.
Okay, I got it.
It's pretty complicated stuff.
Yeah, it is. Okay, so we've talked a lot about like the technical challenges.
Yeah.
What about the user?
Right.
You know, these systems are collecting a lot of data. It makes you think about privacy.
Absolutely. And it's something that everyone working in this field needs to be mindful of. You know, we need to make sure users understand what data is being collected,
Right.
how it's being used,
Uh-huh.
who has access to it.
Transparency.
Transparency and user consent are paramount.
Exactly. It's about making sure the technology serves us, not the other way around.
Right.
Okay, so speaking of serving us, what are some ways that computer vision is being used to make a positive impact?
Well, healthcare is a big one.
Healthcare, okay.
Yeah. So algorithms can analyze medical images,
Uh-huh.
like X-rays and CT scans,
Okay.
to detect diseases earlier and more accurately.
It's like having another set of eyes,
It is.
but with superhuman abilities.
Exactly. And it's not just about diagnostics.
Okay.
It can also be used to guide surgeons during procedures.
Whoa, that's amazing.
Yeah, it's like having a virtual assistant in the operating room.
That's incredible.
It's pretty amazing how it's being used.
What other fields are being impacted?
Well, manufacturing, for example.
Yeah, okay.
Computer vision is being used for quality control, catching defects.
Got it.
And of course, self-driving cars rely heavily on computer vision to navigate.
Right, to see the world.
Exactly.
That's awesome.
It's really amazing to see how this technology is already changing so many things.
When we're just at the beginning.
We are.
It's crazy.
We're on the cusp of a new era where the physical and digital worlds will be more intertwined than ever.
Wow, that's a really cool thought.
It is, and computer vision will be the key.
Okay.
It'll unlock so many possibilities.
It's really an exciting time
It is.
to be following all of this.
It is, yeah.
As we kind of wrap up here,
Yeah.
I think it's important to remember that
Okay.
as we're embracing these advancements, we also have to think about the ethics. You know, responsible development,
Yeah.
making sure these tools are being used good.
That's a great point.
Yeah.
Well, thank you for joining us on this deep dive.
Yeah, thanks for being here.
I hope you learned something new and you're as excited as we are about the future of all of this.
It's been a great conversation.
It has.
And until next time, keep exploring and keep diving deep into the wonders of the world around us.